Today's topic, I want to go over some exciting stuff about wireless and how they play a key role with mobility of devices and communication in general. So let's dive right into it. Uh, Objectives overview. We'll be looking at transmission mediums for wireless LANs. Um, Applications and configurations. Okay, so applications and configurations. Then we have the various wireless technologies and standards. We also have the architecture, protocols, and some of the challenges that goes or that comes with wireless LANs in general. So when we talk about wireless LAN, we're talking about wireless local area networks. So we want to look at some of that in general. Okay. So generally, wireless LANs they do make use of wireless transmission mediums, and typically the airwave is the most supportive medium, uh, which is through the use of the electromagnetic signals propagation that we have within the airwaves. Generally, wireless transmission just propagates signals, electromagnetic signals through the airwaves, and they help move informations back and forth within an invisible airway that we have. So that happens to be the key general transmission medium for wireless in general. Anything that relates to wireless generally takes advantage of the airwave, for all kinds of information transmission. Usually, if a signal is propagated within the airwave based on the various frequency spectrums that we have, each signal has various code standard or encoding standards, and when two signals intersect, they can exchange information back and forth. That is, if those devices have been configured or structured properly in terms of their codecs functionalities. So if you are assuming that you had two cell phones making communications, um, one transmits, the other will also be transmitting or propagating a signal, and when those two signals from the two phones intersect, they can exchange information back and forth. It could be a voice call, or it could be a data call, or what have you. A whole bunch of other services that you can find within that. But generally, we're just taking advantage of the airwave with the current support, with support from the electromagnetic signal propagation that our universe has to offer, or that our planet has to offer. And I'll probably say the universe. Obviously, we're going beyond the Earth's, uh, uh, celestium. So obviously, it's across the universe. So that's one great thing about the airwave. They support this invisible electromagnetic waves that allows your signals. It allows you to transmit or propagate information or signals back and forth. And with the right encoding standards or signal properties, you can intercept those signals and interpret them as meaningful informations back and forth. Okay. In terms of applications, There are a wide range of wireless applications that we have. Obviously, today it's mostly data, voice, and videos. You know, uh, the internet for data part. You have your internet, email, messaging, your WhatsApp, and other text messagings that you have. For your voice, you do have your cellular services, Wi-Fi coverage or VoIP services, which is voice over IP services. And then when we come to video, we have, like your YouTubing, streaming anywhere, um, uh, distributed broadcast transmissions for smart TVs where you can watch programs from either, um, what's it called? Is it Rhapsody? Today we have a whole bunch of other media streaming services that we have. YouTube, there's a whole bunch of streaming services. They all fall under video uh, applications of wireless today. You can stream it over your phones, stream it over your mobile devices, uh, or other forms of television devices that you might have. We also do use wireless for other applications like surveillance, um, where you have surveillance cameras with built-in Wi-Fi transmissions, just to give you security for your home. We also do use wireless for a number of tracking, like for real-time location services for vehicle monitoring of fleets monitorings of cars in general. You can monitor the car fleets um, that are being moved across in your regions, so you can just keep track of where they are at any given point in time. And generally, it's true, like GPS services or whatever. But that falls under tracking in general. We also do use it in inventories, uh, especially at warehouses for barcoding through RFID tags. We also do have process monitoring and controls, just to be able to keep track of various systems within factories or assembly line systems, making sure, a manufacturing process through a batch or through a assembly line, follows the right order so we can easily monitor and control it. And all these can be done via, wireless applications, mediums or wireless mediums. We can also use wireless applications and high definition multimedia delivery, as we mentioned earlier, within videos in general, for your distribution video transmission services like your YouTube's and Rhapsody, uh, a whole bunch of other services for mostly multimedia deliveries. We have on-demand streaming. We do have Amazon uh, media services that you can subscribe to and go to stream, your shows on demand anytime you want it. I mean, movies, premiere, and all of that. So really good applications, that falls within wireless or that wireless can support. And finally, they do provide connectivity in difficult applications or difficult terrains or terrestrial locations. Like for instance, remote research labs can use, wireless mediums to help uh, researchers work on various, researches, either for medicine or just pure uh, medical or scientific research across various regions, and collaborate, through that process as well. So we do have all these, key wireless application services that wireless supports in general. When it comes to pure LAN applications, which is where you have where some of these actually fall under, we do have about four general, wireless LAN application categories. Uh, the first would probably be, I would say, LAN extensions. If you want to extend LAN services, where maybe in structures or buildings or offices or environment, campuses or whatever, where you feel like the wired services is too cost effective, is too costly. The cost of it is too high. You could opt for, wireless transmission or wireless application or wireless LANs um, to help increase capacity, within those environments. And that's where you have what you term LAN extensions. Uh, so generally, a wireless LAN can save a lot of cost, you know, especially when it comes to installations where uh, relocation is a challenge, uh, for various reasons, or the structure doesn't support or doesn't allow you to basically wire it up in place. Then you could opt for, the wireless approach. So within that, you'd have the LAN extensions. Okay, a number of universities, campuses do that a lot, especially if they have a spread out, building structure within a confined environment, and you don't feel like using either fiber optic or any kind of cable or wired medium because of maybe the nature of the location and the cost involved. Um, wireless LAN offers that options that you could go for. So it's a really good option. So you're basically just extending your LAN to various places or various buildings that are within a given confinement. Just limited by maybe the structural uh, design. You know, another one is cross-building interconnection, which is also the same approach. You know, uh, uh, actually, most of your extensions could fall within the cross-building interconnections, especially when you have buildings that are uh, a bit, you know, a bit away from a particular main building where a given network service is being provided. Like for instance, hostel services. Assuming a university has hostels, services that is off, the premises of the campus. Then they could use the cross-building interconnection to address some of those needs. Or when some of the various departments are not within the confinement of a given main campus uh, design, you could opt for the cross-building interconnection. The LAN extension is also factored into it. Generally, though, the LAN extension, let me point out that it's usually within, bigger floor, bigger buildings where you want to extend your LAN networks. You know, like for a given factory building, um, a huge departmental store, you could opt for some of these LAN extension options. But for cross building is when you basically the physical structure itself is not within a given confinement, but you still want to interconnect it, and you opt for that cross build interconnection through wireless LAN application. So it's either through mounting a radio antenna for point-to-point connections that you might have. It could be for maybe campuses that are within close proximities, uh, about say 5 kilometer radius. Yeah, you could use that for that purpose. And through bridging and other means of interconnecting LANs, you can address your uh, cross-border connections via the wireless LAN application. The other one is your nomadic access. Usually, nomadic access, the key role is to provide a wireless link between LAN hubs and mobile data terminal equipment, so equipped with antennas. So devices, so mobile terminals that have uh, uh, that needs to connect to a LAN hub can opt for the nomadic access. Um, your laptop could be a good example. Laptop computers or notepad computers could be a typical example for that in terms of how nomadic access structured or is designed or is applied within wireless LANs. So you could be within a very different locations and still access, LAN resources from a given corporate or institutional, network. And that's usually termed nomadic. Um, a number of nomadic access are quite useful in terms of extended environments such as campuses or business operations that are out of a clutter buildings. So generally, if you have, um, clutter building within campuses or business environments that cuts across a larger campus, and you still have users that need access, you can go through a nomadic access um, using their laptops or their mobile devices to access um, the resources within that given environment. Okay, so that's the option for your nomadic access. Okay, providing wireless link between LAN hubs and then more of your mobile data terminal equipments, which could be your mobile devices or your laptops. Okay, generally the transfer, most of these are able to transfer information back and forth from servers and organization houses, resources that within organizations or various institutions or campuses or whatever, that users need access to either through mobile terminals or whatever. And then you do have your ad hoc networking. An ad hoc network is usually a peer-to-peer network. Generally does not consist of a centralized, server, and it's usually set up to meet some immediate needs. Um, for example, a group of employees, each with their own laptops or mobile devices, for convenience sakes, convenience purposes, wants to attend a conference, or wants to be part of a conference or a video conferencing, like what you guys are doing these days, you know, uh, with Zoom, Zoom lectures or whatever, you know. You can link up through some of these medium for temporary connections, so you can access services that it's been hosted by given lecturer or given institution or given business. And so in that option, you're looking at the ad hoc uh, network, part of the wireless LAN application. Okay. So moving on, we do have some applications over here, other applications for wireless LANs that connecting various access gateways, ISP services for mobile transmission or for mobile services, either via your 4Gs or 3Gs or what have you, from home for home connectivities, hotspots, office buildings, and what have you. We do have a number of, wireless applications uh, that you can offer within the wireless LAN uh, implementation. Now, let's look at configuration. Configuration. So all of these, we talk about applications, obviously, for various wireless setups, within all these environments. Let's look at some of the, configuration. They do require configurations, obviously, because you trying to extend a LAN or through a cross-border interconnection or pneumatic access all requires some specific configurations. So at least there is some kind of uh, consistency in the implementation, so users can be able to access the resources or the information that they need access to. So let's look at a single cell wireless LAN configuration and some of the key elements that goes with it. So in this diagram, we do have a number of stuff going on over here. You do have your bridges. You have bridges or routers. You have Ethernet switches that are supporting 100 megabit per second transmission, connecting to servers and other workstations. And they do connect to what you call CM, which are your control modules. Control modules are generally devices that provide, uh, other control measures or control mechanisms to support other devices that are now within the more or less the wired medium. So in this scenario, we do have the wired medium over here. And then for the wireless medium, the control modules take over to help us support the wireless LAN configuration. So we're extending more or less the LAN uh, connection over here using, the fiber optic Ethernet switches, routers, bridges, whatever, to provide access to devices uh, that cannot physically be connected to the wired, medium. Okay, so you do have your laptops, uh, over here maybe providing pneumatic access, you know, or even extending to, your cross-build interconnections. So your general control module is the key to allow for devices or that interconnection for cross buildings to be established, you know, and I can basically extend the wide connection or the wide LAN to other devices through a wireless medium. We also do have a user mode, and generally the job of a user model is to help with the connectivity that relates to controlling user access in terms of logins, authentications, and what have you. Uh, you could also say this creates a really good pneumatic service, especially for clients that are connecting remotely. to a corporate wide network. So obviously security becomes a key uh, implementation within the user modules of this single cell wireless LAN configuration. So key here configurations must go into some of these modules in order to make sure that information is being accessed from the wide medium well secured. Errors and authentication and security, privacy, whatever are all well addressed within that. Okay. Um, do read the textbook on some of the key elements that goes within the um, single cell wireless LAN configurations, so you can identify them very well in exams or whatever, and be able to describe them. How their functionalities and what have you that you might have. Okay. Um, Other configurations that you'd have in terms of infrastructure. Here you do have high-speed LANs as the main backbone uh, to interconnect the wireless LANs. Okay, so here you do have your high-speed backbone, which could be fiber optic, hooked up to switches, could be bridges, routers, or what have you, and those can support, either wireless transmissions for cells that are within different geographical locations or different areas, you know, as well as even nomadic stations. So at least you have a backbone supporting a cell of mobile devices from a given location. It could be a business, institution, or region, or research lab, whatever. Uh, and then if we're also supporting nomadic stations connectivities or other in non-cell implementations. So here basically we're looking at the core infrastructure that would help support the wireless LANs. Ideally, it's always actually just about every wireless LAN implementation does have a backbone to it, which is on a wired LAN. Okay, so like for instance, your ISPs that are providing cellular services for your mobile devices, most of their connections are all powered over high-speed backbone wired LAN, and they just extend that transmission through their radio antennas, either via microwaves or sector APs, or what have you, to extend capacity to mobile devices within cells and other remote wireless applications or services. Okay. For ad hoc implementations, this is a good scenario of how an ad hoc implementation is. There's no central hub, it's just multiple devices, stations, or whatever. Um, exchange information or collaborating or linked together through their own wireless antennas. So in this scenario, there's no specific central point or central connection or central server that these devices actually are linked to in terms of distribution or connectivity. They just, by themselves relay information back and forth uh, to create this ad hoc wireless LAN that can address a temporary solution, to a given, it could be a video conference or file sharing or whatever, peer-to-peer file sharing. I'm pretty sure some of you do that. If you have a laptop, your colleague also has a laptop, and you have a file that you want to share